my name is Luis Sarmiento, and I am doing a recording for INTE2547 assignment 2, and I am doing the question 3 or section 3. What's that? My student ID is S4117023. So to start off, I'll show that I'm actually doing the work. So Luis Sarmiento, whatever, we'll say I am here, or that's 2, 3. So yeah. So for this one, we need to get some files. So I already have the files here. I've actually done this already, but I'll show you it in my folder. Go downloads. As you can see, I've actually worked on this stuff already, but I'll show you a walkthrough. So we'll delete these. Trash. We'll delete these. Yep. Check it out. Just keep it there just in case, but we don't need it. You can see that's the stuff that we need. We needed this image. I'll show you the image actually. It's what it looks like. It's just two shapes, white background. Perfectly done. So in order to start this, we gotta do input a bunch of commands. So the purpose of this is we're gonna see if encryption is if the difference between encryptions. So one of them we're doing CBC and the other one we're doing EBC. So we're doing the difference between the two. So for question 1, it asks how could we encrypt and what commands, Linux commands, that we need to encrypt this image. It's pretty simple. So we'll go into our what's it called, our downloads folder. We're gonna run this command. I'll put it in now. So this one, this one is a command. We're using a key. It is in let me just remember. It's in, I think, 128 bits, 32 bytes, I think. Yeah. So this is in 32 bytes. And we got to do this so we can create a key for it to be decrypted. So how I came up with this, I just came up with my student ID number repeated twice each time. So 441177002233, and that same thing is repeated again. AA44111177002233. So that's my key for ECB. But for CBC, we'll be using an additional key as well. If I remember, what's it called? It's using a, yes, initialization vector. So yeah. So yeah, we're gonna be doing this now. Let me just run this. So you'll see it'll create on the downloads folder on the right, you'll see it'll create something. Yes. So as you can see here, pic_ecb.bin was created, and that is our encrypted image of that pic original.bmp. With that, we can look at the G hex of it. See it, all different. It's all different. But if we check here, let me see. Open. If we see here, we compare it. It's all different. It's all different here. Okay, so that is one way to encrypt it. We're going to do the other one, which is CBC. So it's similar idea. Let me see. So I'm gonna copy this. I'm gonna copy it here. And you're gonna see what I'm talking about, the IV, the initialization vector. So I'm gonna put that here. Oh no, this is decryption. My bad. That is not the correct one. Sorry. Encryption's here. My bad. So encryption for that is here. So when we do this one's going to create, it's exact same. It's going to create another encrypted file, but it's under CVC encryption. So we'll do that. And by the way, how I got to this was I put my SID ID number same, but I put in zeros in between each before one number of my SID ID. So instead of 4117, it's 4010107000203. So yeah, exactly the same. Do it, repeat it again. So we're gonna put that in. And as you can see in these top two files in my download folders on the right, you can see that it's created CVC as well. And if we compare it, compare it with this, it's different. As you can see, it's different. Different starters, different everything here. It's a different encryption method. So in order to compare it, I'm going to show you the difference in how these encryption works. So first, I'm going to encrypt it and show you that the file has not been tampered with. So that's why I gave the decryption earlier. So I'm gonna decrypt ECB first. Copy. Yes, and I'm gonna decrypt. I'm gonna decrypt as well the CVC. Do that now. Okay, so you can see this is a decrypted one, and a decrypt. Both of these are the decrypted. So we'll compare it. Actually, we'll actually compare it. Oh wait, my bad. Yeah. So that's a decrypted one. I'll show the unsigned float. And this is the decrypted one for ECB. Straight off the bat, you can't. There's no difference. It's not. It has not been on. It hasn't been touched at all. As perfect. This one. Oh wait, no, wrong one. And then we'll see with the original. I'll compare with the original one. That was the main purpose of this. As you can see, it has not been touched at all, which is perfect. Which is very perfect. So with this, it shows that it hasn't been tampered with. Integrity is being kept. So yeah. For question 3, question 3.3, yeah, 3.3, I will show you moving the first 54 bytes of the decrypted of the original BMP file to the encrypted one. So I'm gonna show you what it would look like. So what we're gonna do this here. So let's see. Let's put this. Let's start with ECB first. So 54. So this is 3, 6, 9, 12, 15, 19. Let's do even 20. 20. So 2, 4. Okay. So that is 8, 9, 10, 11, 12, 13, 14. Wait, sorry. I can't see. 4, 8, 12, 16, 17, 18, 19, 20. Okay, that should be 20. Unless I'm tripping out. 4, 8, 12, 16, 20. Okay, it is 20. Yeah. Sorry, I'm tripping out. Okay. Okay, so this is so 20, 20, 40, 44, 48, and then this is 52, and then that is 54. Okay, perfect. So from C6, that's going to be removed because we're going to go here. Remove, select here. And then I think this, yes, it's already, yeah, perfect. So what I'm going to do here, I'm going to move, oh, sorry, I'm going to remove the PC dot underscore ECB dot bin first 54 bytes and replace it with the ones from pick original dot BMP. I'll show you what I mean here. Edit. This one's copy. And for here, we're gonna do in edit, replace. Oh wait, no. Edit, insert mode, edit, paste. So you can see it has been replaced now, and I'm gonna save that. Yeah, I'm gonna save as into here. I'm gonna make it decrypted decrypted 54 bytes dot. So this is key. We're not leaving it as a bin file, but a BMP file, similar to the one as the original one. Okay, so ECB is done. We'll save that. Now we're gonna do. Oh, spoiler. We'll do CBC. Okay, so this one, 54 files again, we'll do that. 4, 8, 12, 16. Wait, what? 5, wait, 4, 8, 12, 16. This is 20. Okay, 4, 8, 20. So that's 20. And then stop. Okay, 54. Perfect. Okay, so we're gonna delete this again, and we're gonna replace that with the pick underscore original at BMP. So we're gonna do this again. Edit, copy, then here, edit, insert mode. Then we're gonna paste. Yes, paste. So you can see it's be replaced. So we're gonna do the exact same thing. Save as decrypted 54 bytes. Yes, and then we're gonna don't forget BMP file. So this should develop an image. So what we're gonna see here, we're gonna compare it. So you can see with CBC, nothing. There's like you can't even make it out what it is. You can't even see what it. We'll even look. Bro, there's nothing. Oh well, exit out of there. But here, let's go. Am I? Oh yes. My goodness. You can see what the shapes are from the original image. And here's the original. Yeah, you can still see and make out the shapes of it, but not the color. So so you can see the outline kind of. You can see outline. That's the original image, and you can still make out what the outline would be, which shows that ECB is actually not the recommended one for image encryption. Rather, CVC would be perfect.